the second example, it gives you a sept analysis and hydrometer analysis, and asks you to plot a combined grain size distribution curve. And from the plot, ask you to determine the percent of gravel, sand, silt, and clay based on SHTO classification system. So this is the question. And in here you see, in this question, it gives you two analyses, right? In the previous one, we just did the sept analysis and did the sept analysis related calculation of sept analysis. And why we have hydrometer analysis? Because we say that sept analysis is cannot get the very small particles distribution, right? Because you see for a sept, you cannot always make it very, very fine, right? You can't make those holes on the sept very, very small. So it is limited. But with hydrometer analysis, we can analyze the particle size distribution in a very, very small particle range, right? So if you want to go to a whole particle size distribution curve, you'd better combine these two analyses together. Combine these two together. And in here, the example gives you the sept number, right? And the corresponding opening for each sept, and the grain diameter in the hydrometer analysis. So actually the x-axis you got, and the percent pathing. It also gives you this. So actually, it's easy to plot the particle size distribution curve. It is in here. What you need to do is just plot those points together. Got this. And in here, the left part, those points is from the sept analysis, and the right part, those points, is from the hydrometer analysis. What you need to do is just connect them together in here. And there is a joint in here. It doesn't matter you plot like this, or plot from this way, right? It doesn't matter, as long as it won't affect the final results a lot. Okay, so we can easily go to the particle size distribution curve. But in here, it asks you from the plot to determine the percent of gravel, sand, silt, and clay based on SSHTO classification system. So we said that based on different code, different system have the different delimiting particle size for gravel, sand, silt, and clay. We have such a table on our textbook. You see that this is a different organization. The MIT have their delimiting particle size for gravel, silt, sand, and clay were different, right? And for EASHTO, it's different with MIT, right? Right. So this is why the question asks you to, the question fixed the classification system, because if it asks you to determine the percentage of gravel, sand, silt, and clay, but didn't tells you which system you should follow. So you may got different results, right? Because we have different code to follow. And in here it asks you to use this, that is this line, right? And based on EASHTO classification system, so the delimiting pore size between clay and silt is 0.002, and for sand and silt is about 0.75, and for gravel and sand, the delimiting pore size is about, particle size is about 2 millimeters. So how to do this? Let's see. For gravel, if we based on this system, gravel for this system is the particle size higher than 2 millimeters, right? between 2 to 76.2 millimeter, right? So we find the 2 millimeter on the particle size distribution curve in here. It corresponding to a percentage of 98. So higher than 2 millimeter, that is the percentage in here. This part is the percentage of the gravel particle, right? So the gravel particle, the percentage for gravel is 100 minus 92, right? It equals to 8%. Why minus? Because we said, again, the accumulative percent is the accumulative percent for those particle size, for the particle lower than this particle size, right? But in here, the gravel is the particle size higher than 2 millimeters, so it is in the right side of the plot. So you need to use 100 minus 92. So gravel have a percentage of 8. And then it is sand with the same way. Sand, based on those classification system, is a particle between 0.075 to 2 millimeter, right? Right? So 0.075 is in here and 2 is in here. So the percentage between 31 to 92 is a percentage of sand, right? So the sand should be 92 minus 31, it is about 61%. And then with the same way, silt is a particle between 0.002 to 0.075, right? It is between 0.002 to 0.075. So the range is in here. So silt should be equal to 31 minus 10, right? It's around 21%. This is the percentage of silt. And then finally, the rest is clay, right? Clay is a particle smaller than 0.002. So smaller than 0.002 is the percentage of this part, right? It is about 10%. So this is what we can do with sept analysis and hydrometry analysis. So finally, from the particle size distribution curve, what we can do is determine the D10, D30, and D60, and then based on this real value to got the Cu and Cc, and then based on Cu and Cc define if a soil is well graded or gap graded, something like this. And then also we can use a particle size distribution curve to define how much gravel, sand, silt, clay in a soil, right? So this is how to do analysis with a particle size distribution curve. Then we finished this chapter.